We're now going to talk about how we can find the complex zeros of a polynomial function. So let's suppose for a moment that we have the polynomial function x to the fourth minus 3x cubed plus 6x squared minus 12x plus 8. And we are now told that one of the zeros is 2i. Well, we know that there's a total of 4 zeros, and we now know 2 of them. We know that we have a 2i and we have a minus 2i. We have to have its complex conjugate. And so what we're going to do is we're going to multiply these out. We're going to get x minus 2i times x plus 2i. That gives me x squared minus 4i squared, which is x squared plus 4. So here's the important part. We have an x squared plus 4, and that accounts for 2 of them. But now what I'm going to need to do is divide the x to the fourth minus 3x cubed plus 6x squared minus 12x plus 8 by x squared plus 4. So what times x squared gives me x to the fourth? That's just an x squared. That gives me x squared plus x to the fourth plus 4x squared, which we then subtract. Bring down the minus 3x cubed, bring down a positive 2x squared, and a minus 12x. That's a minus 3x to give me minus 3x cubed minus 12x, which when we subtract, that means we're going to change the signs to positives. And we get 0, bring down a 2x squared, and an 8, and we add 2. 2 times x squared is 2x squared, 2 times 4 is 8, which when we subtract, notice we get a remainder of 0. So x squared plus 4, sure enough, is a factor of this, but the last piece that we have is the x squared minus 3x plus 2. Well, this is easy. We can factor this. Factors of 2 that add up to minus 3 are minus 2 and minus 1. So my zeros are x equals 2, x equals 1, x equals 2i, and x equals minus 2i. And we've now successfully found all of our zeros when we were given one of them.